We are back on Maze, 3D Maze. So, just as a reminder where we are. Let's boost the font, because I know it's gone down. Can you see that? Yeah?
Stop it.
Right, so F6. So if you remember, we've got one of Stacy's specials. I think he's on. You on, mate? I think you're on. I thought I saw your name up there somewhere. So we got the front screen, the splash screen working. And then we got this, where we, I forgot the controls. Aha! Where we got the indicator of easy, medium and hard. But one of the things is I like this. I like this flashing, this cycling through the colours. And I'm thinking of doing it on this, in hard mode. Here, I'm thinking of getting this to be cycled, like we've done on the menu screen. But also, I was thinking about when you move it, instead of it instantly moving, it shoots across. But I don't know whether it's worth the effort doing that, to be honest. Well, instead of it going, it floats to it. So you press it, it goes to it, but quickly. I'm not too sure. I'm still unconvinced. But I definitely want to do this. I definitely want to do this colour on the difficulty, the high difficulty. So let's find where I do it so I can copy it. So, where is it? Display, there we go. Raster. There we go. Cycle sprite color, that's what we want. So, on the... So, where it says difficult, in the raster, here we go. Now we're doing it inside the raster, aren't we? No, we're doing it on the cycling. Okay. So we do it here. So what we need to do then is in here, LDA storage dot difficulty, command it with hash diff hard and branch if equal to bypass hard. And then we do that there. So if it's not hard, then we're not going to cycle. So we're looking at difficulty. What's the namespace for oh, it's difficulty. The namespace is difficulty. Right. So let's see if that gives me what I want. Right. so it's not. Am I using the same sprite? Sprite color 0. Yeah, so I'm using the same sprite. Okay, so I'm using the same sprite, so why is it not showing? Well, that's the white. Sprite color 0, let's do this. We're not using frames. Branch if equal to 0 to bypass hard. That's right. Is it updating the timer? Put a breakpoint in there, see what it does. Right, so it is definitely doing it. You've been on the phone. I'm trying to get it to cycle through the colour. But it's not doing it. It's not doing it. Even though I've set up sprite to 0. It's not doing it. Unless I'm setting it to white every time we do it. So that's what we're going to find out. Right. And that was wrong. Right. That's the one. So it set it to white, and now we're going to go into here. So we're going to find out what's wrong with it. Branch if not equal. Oh. O8 E2. That's there, so it's at 5. Right. Decrease it. It's 4. Branch if not equal to 0. Okay. 4. Oh, it's doing. Oh, it's going back to 5. Oh, okay. Oh, right, can you? So you can. Well, that's another trick that I've learned. Right, let's find out why this is going back to Right, so let's go back to 08 CE. So it's gone back to 5. Okay. Right, it's gone back to 5. So, are we using that somewhere else then? Current frame. Where are we using current frame? That's alright. Oh, timer. We're using it in the timer. Yeah, we're using it in the timer. Right, okay. So I can't use the current framing because it's using it for the timer. So we will create another one. So game storage. So we'll copy that. And we'll put that and we'll say current sprite frame. And we will use that in there, in there. And we'll use it in there. Right, that should fix it. So it's still working there. That's better. Has that clock gone slow now? Where's my stopwatch? Right. Started at 15. Yeah, the clock's gone slow. Yeah, clock's gone slow. I don't know if it was half the speed, but it's definitely gone slow. So what are we doing? Hey Proton. Are they supposed to be seconds? Yes, they are. So us doing our cycling of the arrow has slowed it down. So what's the frames seconds? So it's 10. Okay, let's drop it down. Let's do 8 because I think it was only just slower. Let's do another timer on it. Right, I'm going to start it at 10. Oh, it's still slow. Right, that was 10 seconds and I counted, I counted up to 16. Right, let's reduce the frames even more then. Right, let's try that. So I started at 10 again. Well, it's not even coming up now. Oh, that took a while. And I'm going to stop it when it gets to 20 on the 64. That looks about right. Looks about right. So we'll leave it at that at the moment. So it's back to the timer's 5, which would be right because we are 50 frames a second and we want it to update 10 times a second, so that's every 5 frames, so that's right. So what I was thinking of was trying to put some bad guys in there. Oh, my seat is playing up. There we go. Try and put some bad guys in there. Girlfriend wants to play cards. What's that phrase? Bros before. See you later, mate. So what I was thinking of doing was I was trying to think about how to put some bad guys in, and I was trying to think what sort of AI we could have on the bad guys, and oh, them sort of cards. So trying to figure out the AI for the bad guys. So what I was thinking of whether to have a bad guy that would always chase you no matter where you are. So it would try and figure out where to go no matter where you are, or we just get them randomly picking a direction from where they are. But the problem of targeting is we've just seen how long it takes to solve the map, yeah? So we've just seen how long it takes to solve the map. So it would take that amount of time so if the bad guy was here and you was here, to get to you, yeah. And I'm not too sure. I'm not too sure we can afford that sort of time every time a bad guy moves. So I did want him to target you and follow you. Yeah, but the problem is, how do we define what the AI does? Yeah, because in Pac-Man you've got one that runs away, one that's chasing you, one that gets close but not close enough, I think, isn't it? So yeah. So I don't know. I was hoping that the targeting would take less time, but when I was doing it earlier, you know, this solving of the map takes about half a second to a second, depending. Let's do it again. Not that bit, this bit. See, that took half a second at least. But we don't want it to take half a second every time it moves, because it's got to if you want it to target you, it's got to evaluate where you are all the time. So what I'm thinking of is just getting it randomly to choose, and the AI just wanders around, so to speak. So yeah, so that's what I was thinking of doing, was trying to get the bad guys, to evaluate, put some evaluation in there and try and get it to do it. So, and then work out if we're going to do any AI. So first is randomize. You know, we evaluate where they can go and then randomly pick which direction. Do we allow them to pick where they've come from? Ooh. Still want a targeted one though. So if you go, just thinking this through. So if we have them randomly picking where they're going, if they go down a dead end, and we say that they can't go back on themselves, then they'll get stuck. That's an interesting one. How do we do that? We'll just get them to randomly pick a direction for the moment. We'll get it to randomly pick a direction. So let's create a new file. Called bad guys, like I normally do. No, it's just to stop them doing that. Yeah, it's just to stop them randomly picking backwards and forwards, backwards and forwards, backwards and forwards. Yeah. Yeah. Yeah, and that's what I was thinking. We're going to have to work out those different scenarios. So let's create another file called bad guys. And that's put it in the wrong place. Out you come, boyo. Not in there. Right. Do the same thing as we've done before. So what I'm doing in Pac-Man, okay, is that they hit a wall, they can go back, but then they hit the special square at the junction, okay, and then are allowed to change direction, but not go back on themselves. Alright, so you don't allow them to go back on themselves. You don't allow them to go back on themselves when they're travelling. You don't allow them to go back on themselves at a junction but you allow them to go back on themselves if they hit a dead end. Okay. Okay. Yeah, we can do that. We can do that. Or a wall. Well, we've got dead ends, so we can definitely do that, because what will happen is we'll evaluate the possible exits, and if there's no exits, then we can get them to go back. Yeah, we'll do that. We'll do that. So we need an array of bad guys. Yeah, exactly. That's what we're going to do. So Stuart's going to put in my case, dead end, they can go back on themselves, but when they hit one of the junctions, they can move in any of the directions apart from going back on themselves. Yeah, so that's what we'll do. So we need a byte to number of... Right, number of bad guys. We'll start with 1 at the moment. Current bad guy. Make that 0. So bad guy X. So it's number, isn't it? Number of bad guys, comma 1. We'll say that's the default. Do the same for Y. What else do we need? Bad guy last move. Oh, my arm. Right, bad guy last move. So that is... We are going to use... We'll use this. So we'll say that they went left for the last move. What else do we need? We need to know where they've come from. Which, oh, should not say which direction they went on the previous move. So if they went left, we couldn't go right. Their X and Y. Right, we'll put type in there. We'll put type in there, just in case we add different types of bad guys. We'll say 1. That should be it. that should be it. So, right, so I am going to max X. So we're going to say is that divided by 2, so it starts in the middle. So the bad guys start in the middle. So that will initialize them as the half size, but we'll initialize it anyway because every time the game plays, we'll have to initialize the arrays anyway. So it's just a thing to put in there. Right. So what else do we need? We need a frame counter, don't we? So the guys will not run on every frame. We'll have a frame counter that... So they'll move every so often. That's if we make the frame, if we make them move quicker than us or slower than us, I think. In fact, no, we'll not make it too difficult yet. We'll just keep it global because all the different types could have different speeds. Right, let's get started. Right, so load bad guys, number of bad guys. So LDX bad guys. That gives us the number of bad guys. And so bad guy last move, comma X. Maze max X. Yes, we're going to be adding enemies to the maze, so we'll divide that by 2, so that's gonna LSR, store it in bad guy X, comma X, do the same for Y, and we'll leave bad guys type at 1 at the moment because we're just going to mess around with just 1. Right, so DEX branch if not equal to yeah, well, eventually, I don't know how we're going to represent the bad guys in the 3D view, but it's the suspense, yeah, of being chased. That's what we need to do. So we'll figure out how we're going to visualize it in the 3D model, in the 3D version later on. But it's just the fact that we've got bad guys in the maze chasing us that could potentially, you know, sort us out. So, so that's doing that. That's doing that. So that's initializing the bad guys. Okay. So we just need to do. We just need to loop through the bad guys. Currently, it's only one or two, I should say. And evaluate where we can go. Now, the code up for this is already written. Because we do it when we yeah, that's the sort of thing that we'd probably be doing, is we'd have sprites at the different slices, and so we'd have to use more than one sprite and stuff like that to make it look like it's coming at you bigger. But you know, that's the sort of thing that we'll look at later on. All I want to do is to try and see if we can get the logic on the maze. So we need... Where's the maze?
Hello, John here. Thank you for following. Hope you enjoy the stream.
Oh, I got a new follower. And my system still doesn't see the follows. There we go. I've just seen the message that you put on the subscription, mate. I can't get Retro Debugger to work. I've just seen that. Oh well. Right. So, ow. Do you know, I rang Doctors again today. Couldn't get me in. Apparently I've got to ring up at 8 o'clock in the morning if I want to see a doctor. So I rang 111 instead. What's up, mate? What's the matter? What's the matter? Hey? You want to say hello? Or are you just pestering me for a bit of a tickle behind the ear? Hey? Alright then. You stay there then, yeah? You going to stay there? Right. Map, maze. I think it's in there. Solve maze, here we go. Welcome, Nosob. Welcome to our my little portion of the internet. I've got Nico behind me for some reason. I'm not too sure what's the matter with him.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Hey! Adam Twine. Hey, mate. Thank you for the gift sub. Gray, you're a part of the subscriptions now. Thank you very much for the gift sub. Very kind of you. Very kind. Oh, and mine hasn't done the gift subs either. Oh, I'm going to have to sort this bot out. Right. So here we are. This is where we solve the maze. And what we do is we go through the maze and check where we can go, yeah? So that's what we'll do here. So we'll do exactly the same as what we're going to do here. So we'll copy this bit. Get current location, check where we're going. And then we should have a random check. There we go, how many exits? And there's the random pick. Right. So we'll just copy a little bit of it. So we'll bang that over on that side. Go back to here. So what we're gonna do. So we need to run through the bad guys one at a time, evaluate where they are and what they can do. So if they're in a tunnel, they'll only have 2 exits, yeah? Where they've come from and where they're going. So that's it, yeah? So we'll just keep them going in the direction that they went last time. If we have more than 2x, no. We'll have to ignore where they've come from. Yeah, right. So let's get this thing started, shall we? Right. What's up? What's up? Hey? Come here. Say hello. Come and say hello. Come and say hello. What are you growling at? Say hello. Say hello. Hey, say hello. You alright? Hmm? Hey, alright. Alright. You alright? Okay, I'll put you down now. Hey, less of that. Less of that. You're lurking, mate. Yeah, he's... I don't know what's up with him today. Maybe it's the medication, because he just had the medication before I started. Anyway, right, so... we're going to run through the bad guys one at a time, and we're going to evaluate what we can do with them. So, we will, yeah, we'll do this, and we'll put that in there so we know where we are. Right, we need some no, that should be all right. We should be all right. Right. Let's get some data stored. Right. So we've got bad guys X. That's the array. Do we need a single place? Good question. Yeah. So Right. Oh. Stupid arm. Right, so, bad guy X. Right, so we've got two temporary variables where we're going to store the X and Y, and the reason I'm doing that is because we're going to be messing around with those values while we're doing the evaluation. So this is what we need to do here. So I'm just wondering, JSR evaluate surroundings. There we go. That's what we'll do. Right, so we'll do that. We'll initialize how many exits. Stop that. And then, right, look at the current location. Right, the current location, we'll know what that is. So this is going to be maze, I think. So the current location is bad X and bad Y. Current location, I'm sure that's maze. Yeah. Oh, it's not. Okay. That's inside the namespace, isn't it? Oh no. Oh, it is. I should sort it. There we go. Right. So we load our current position, and we should then we'll evaluate our end result. That is not what I'm after. I'm going to say that looked wrong. It's solving, isn't it? There we go. I was going to say it looked a bit wrong. Right, so So we need to do exactly what we've done here. We're checking for up. In fact, I'm going to copy all this lot. Right, we'll copy all that lot and we'll paste it in. And then we'll strip out what we don't need. Right, so it's different than the build and the solve, right? Because the build we had nothing, so we checked that there was nothing. With the solve, we're actually checking that there's exits, and that's what we're doing here. So we're saying get what's at our current location and store it in the available exits. So have we got a possibility of going down? Yeah, and in fact, yeah. Right. So we're checking to see, can we go up? If it's 0, means we can't go up. Yeah? If it's not 0, then we know that we can go up and our backward is going down. But we're not doing backwards here. We are not doing backwards because all we're doing is saying what's our available exits. So what we need to do is this. Yeah. So if we can go up, that's our available exit. And then we need to check for down. So let's go to down. That's here. Load, check. Let's copy that. We don't need to check further because all we want to do is go down. So if there's an exit that we can go down, that's an available way of going down. Then check left, which is here, and so we get rid of all that lot and just say that left is away and right is there. So we should have a set number of exits. Now what we need to do is we need to check where we come from so we can eliminate it. So so that's that. So the last move would be the opposite way. So if we've gone left, we would, yeah. If we've gone left, we can't go back right. Yeah. So what we need to check is that we haven't come from that direction, yeah? So LDA that comma X. Now X has been destroyed, so we need to load it back in. Right, so we load it in, compare it with direction up, branch if not equal. So if we've not come from that, no, branch if equal. If we've come from that, then we need to go to the next checkpoint, which is that. So we can't go up. If our right, let me just work this out. If we're checking up and there's an exit, we can't have come from down, not up. It's the opposite, isn't it? So if we've got an exit upwards and our last move was down, we're not going to go back up, so we bypass it. There we go. So we'll do the same for this. This one is for up. Yeah. Then this one, oh, stop with all the thingy. Right, so this will be right. And this one will be left. Right, so oh no. Well, there's another way of supporting me. You could become a patron. That's another way. But subs is as good. Right, so we should now have an array of possible directions, yeah? So what we need to check now is if there's only one exit, well, in fact, no, because we don't do anything. Cash in an envelope. Yeah, meet you on the street corner. Such and such a time. Hang on, I'm just thinking this. Am I overcomplicating this? No, I'm not. So, yeah, we'll test the way we've been. So that leaves us the ways we go. If we've got one exit point, that's the way we're going to go. If we have more than one, we'll do a random pick. If we have 0, hey Ryan, yes, we are old school. We are not afraid of it. We are definitely old school. So here, so let's think this through. So if we are equal to 0, if we are equal to 0, we need to go in the opposite direction to where we came from. Because we was in a dead end. So if we went left and then we're blocked, we need to go right to get out of it. Yeah. Well, we can get to, we'll talk about that when we get to doing all that, mate. Yeah. At the moment we're just trying to do the simple stuff. Yeah, definitely random. So just trying to work out the logic. So 0, so if we've got no exits, so we've moved and we've just evaluated where we are and we've got no exits, that means we're blocked in. So we need to go, we need to reverse the direction. A layout sketch on paper is not going to do us any good here, mate, because we dynamically generate the map. We dynamically create the map. But I can try and I haven't got the tablet out because I didn't set up properly. my little graphics tablet. So we're going to have to do this again. And rely on my mouse. So we've got potential mazes. So this is dead easy. We are here. This is us. We've come from this way. So we have one exit. So we can just move straight into there. Yeah. The one I'm considering at the moment is this one. So we came from there. We got one exit. We move into it. Then we're stuck. Yeah. So we need to go into the opposite. We need to then say, right, our direction's changed, and flip our direction. Yeah. And then for junctions, which this would be a typical junction, we're here. Yeah. So we've come from there. So we don't evaluate that, but we evaluate that this is an available exit and this is the available exit, and then we can randomly pick which way we're going to go, which then if we pick this way, then we go that way. So that's the logic. Yeah, that's the logic. So we're just trying to put what we've just done on the screen into now. Nowhere to go. Nowhere to go, which is there. Right, nowhere to go. Ah, here we go. That's how we reversed it. That's how we reversed it. I was trying to think how we reversed it. Right, so so we'll do, we'll do the, we've got nowhere to go, which is here. Yeah. So it's this here. There we go. So we have no exits. Yeah. I made a cock up. I put my stream on straight away without the warm up bit, so I haven't got everything out. So this is the routine where we reverse our direction. So we know who we are, which is here. We know who we are. So then we need to clear, add to, and it with 1, 2, 3, 4, 5, 6, 1, 2, and we'll store it back into there. The direction stored is there in the last move, yeah? So let's think, let me just think this. We're in the spot, and we're blocked in, so we're already in the spot. You've sent an idea for an enemy. Dude, you are once again knocking them out of the park. Hey, hang on. Oh, and it's animated as well. Let's blow that up. Oh, whirlwind. A tornado enemy. Tornado enemy. Oh, Taz. Yeah. Whoa, we'll definitely have to do something with that. I love it. Love it. We'll have to do something with that. Excellent. Yeah. We'll do something with that. Right, so we'll store it in the last move. Have I got a new patron? Come on, phone, wake up. Oh my, I've got a new patron. No sob. Thank you very much. Thank you very much, mate. If you join my Discord, mate, and link your Discord with your patron, you'll enter the golden family, which is the patron family. Thank you very much for your support, mate. Much appreciated. Very much appreciated. Right, so we're going to store the last move. So we have updated the last move. So if it was left, it'd now be right. Yeah. If it was up, it'll be down. So we've stored it. So now we need to go and say jump to. In fact, we don't. We can return out of that because this is a routine in RTS. Right. So the next one is we have a place to go. So we have got right, let's think this through. We need to check how many exits we've got. So we've tested for 0. If we've got 1, that means we're in a tunnel. Right. So let's do this. So we'll load that back in. CPX #1. If it's 1, that means the direction that we are still in. So we're not going to change it. Yeah. No sub. What tier did you pick? I'll check it. Oh, you'll get an automated email anyway. Right. So if we are 1, we don't need to update it. So we'll go branch if not equal to more. No, we'll say at a junction. Whoops. If we've only got the 1 exit, we can just return out because we don't need to do anything. So now at a junction, we're going to do the randomization. Yeah, which we've already got here. So, my arm. It's very difficult to think when I've got pain going through my arm. Right, so we have more than one exit. So we can pick any one of those. Right, so we'll just copy this. No need to randomize. Yeah, that's the thing. So this is the one we're looking at now. So we end up with a random number. So we'll pick where we're going to go and then store it in. So we need to pick out, right, so we need to pick out what exit we're using, which is this. Then we need to pick out who we are. In fact, it's all this lot, isn't it? Right, so that's it. So we've checked where we can go. So we've evaluated the surroundings for that particular bad guy. Now we need to move him. We need to move the bad guy. Right, so let's create another one. So, let's see. I want to put them on. I want them to be seen on the screen. So that's going to be interesting because our status array is full. Our status array is full, so we're going to have to directly put them onto the screen, I think. Right, so right, so we need to work out the colour location, which is here, and we'll do that. So, LDX current bad guy. Now, we have not actually updated our position yet because we've only evaluated which direction we can go. So we can reset the colour. What's the first one? Y. I think you can do that. Let's have a look. I think you can do that. LDY, X. Yes, we can. Good, good, good. Right, so we load the bad guy Y, X, which is the equivalent of this. Get rid of that. Work out our colour position. And then we need to do this again. But this time we're doing X. And we will set it back. I can't remember what the background is. It's yellow, isn't it? I think it's yellow. Is it yellow? No, it's red. Yeah, need to make it a constant, I think. In fact, we'll do that now. Don't think I've got one anywhere. So, what we're going to make the bad guy colour. So, we're green. We're green. Or are we? Or are we? Go back into it. Right, okay, let's do this. So, the solution is purple. The default's red. We are green. And where we have been is yellow. Right, so, you know, where we have been is yellow. Yeah. So, what bad guy are we gonna... So, what colour are we gonna make the bad guys? So, what colour are we gonna make the bad guys? So... we can't make them black. Blue? Cyan? Do we want to make them obvious? Do we want to make them obvious on the map? Pink. Pink? Well, we could change it. White. No, we can't use white because that might interfere. Hang on, that might interfere with that, where you only see part of the maze. Yeah. So what should we pink? That'd be obvious, wouldn't it? Let's have a look. Let's get the colours up. So which one? Yeah, the grayscale's the pocket light, so it goes from dark grey to white effectively. Yellow we can't use. Orange, light pink, which is light red. There's blue, of course. We are not using any blue, so we could use light blue, I suppose. And cyan. That'd be glaringly obvious, wouldn't it? Oh, the pocket light effect. Yeah, it took us a while. We'll make it light blue for the moment, and then we can change his minds if we need to. Light blue, constant color underscore maze underscore us equals green. Ooh, that's not going to work, is it? What else have we got? Solution, wasn't it? Right. Let's find them all. So we'll start with red. And we're going to change it with that. Right, next one is green. I'm going to change it for that. So, green. That's it. Next one. Where's it gone? Trail, so we're looking for yellow. Cool, I've got a lot of yellows in there now. Right, next one. purple. That should do it. Right, let's just make sure we are still working. We are still working. So the colours haven't been affected. Oops, went down the wrong way. Oh, my arm's killing. Really hurts. Right. Okay, so we've got a bad guy colour now. So, no, that's yellow, isn't it? It's not yellow, that is default. Take the default colour, change the colour from what it is. Now we can perform the move. Yes. Right. Which is similar to what we've got here. This is it. This is performing the move. The only difference is we're looking at the array. Right. So we're looking at the array, so we need to load that, and then do that. Yep, and then here we are doing bad guy X, comma X. Yeah, so we're decreasing bad guy X dot comma X, and then we jump to here, where we're going to update the screen. Alright, mate. We'll talk to you later, yeah? I'll see you. I'll catch you Friday. Right. So we've done left. So we've got to do the same with right. So we've still got this intact. So we don't need. I mean, I suppose we could get it to load it again, just to be sure. And this time it's increasing bad guy, comma X. So it increases bad guy, comma X. We'll do the same thing again to make sure. Goes there. Right, so this is bad guy Y, comma X. Right. Then we do the same thing we've just done here. Now that should be still... No, because it will have changed. So we'll grab that. Come down here, put that there, and what do we call it? And that would store it in the new place, and then we can RTS. So that performs the move. So we return the maze back to its original colour. We then evaluate our direction that we're going. And then we put our colour in. So here, so we've done the evaluation. We've then done the move. Right. In fact, that can be there. Lowered that back in. DEX. Branch if plus to looper. And then come away. Right. If this works, I will be amazed. I will be amazed. Right, so we'll put it in. So we need to include. So we need to include it. Need to include it. We need to initialize it. So we'll initialize it here. Initialize it there. So initialize the array. And then we will there. We'll put it there. Right, so that will make the bad guys move for every time we can move. Okay. Let's see if we break it. Whoa, straight away. 167 in bad guys. Oh, where did that go? Oh, that is not happy at all. That is not happy at all. Whoa, what is all this? Have I got that wrong way around? Oh, let's see. Where's kick? Five commas.
John here. Thank you for following. Hope you enjoy the stream.
Soviet Bill, welcome. Welcome. Right, Phil 5,0. So that's right. Phil. Okay, so that command's right. So why is it not liking it? Number of bad guys. Oh, I see. I see. We need a constant, so we will put it here. That should do it. It's better. Right, let's see if we've killed it in any way. Right, so we have got an issue. That's all right. That's all right. Nothing a bit of debugging won't... Right, let's find out where the data's stored first. There's still a lot of data there. Why is that so big? That's 01, that's right. So we've got one bad guy. Oh, right, okay. I think I see where the problem is. I think I see where the problem is. But I don't know what this is in front of it is. See, that's the sprite there. But I don't know what that is. Oh, I know what that is. Oh, I know what that is. Right, I know what that is. That is the title. So what we're going to do is we'll move that to there. Right, so the problem with bad guys is we've got this at 1, but the problem is we're filling only one cell. But, because we're using 0 as well, that's 2 cells. So the number of bad guys is actually, it should be, we'll say 2. But that's 3. So what we need to do is we need to do -1 here. So it only does 2 cells. Right, let's see. I wonder if that helps the problem a little bit. Oh, look at that. It's almost working. We have 2 moving about. Right, let's put it down to 1 bad guy. They're multiplying. Yeah, I think there's a few things going on, but let's just make sure we. Right, so we've got 1 bad guy, which is up there. Now he's wrong. He's just going backwards and forwards. So either we're putting him in the wrong place, or our code is wrong. So let me just see what we're defaulting it to. Right, there's a sprite data. So we are defaulting ooh, that didn't help one little bit, did it? It didn't put any memory in there. Right, so if it's 1, it's 0. Okay, that's why. Right, we'll have to... if it's 1, that should be it. And we've got 2. Would you believe it? We have 2. That means that is that. Now we should have 1. Well, that didn't do any good, did it? Oh, yeah, because that should have worked. Where's the byte dump? Yeah, 0. Oh, I see. I see. Hang on. Yeah, that's what we're going to try and figure out. I'm just trying to figure out why when it crashed when it went straight in. Right, here we go. So we should have 1 guy wandering about. There he is. And he's going left all the time. At least he started in the middle of the screen. Oh yeah, he is. He's going right. Oh, John, come on. Right, so we're going to find out what's wrong now. So we now know it's working. Yeah. So he's going right. Now, why is he going right? I've gone and said he's going... I've defaulted it to going left. Right, so we're going to put a breakpoint here. Where we're going to evaluate the surroundings. Right? So here we go. C64 debugger. Now, why is he going there? Oh, that... Oh... That was... Oh, that's a silly mistake, isn't it? That's the first silly mistake. It's better. Right, so now we're in the evaluate the surroundings for the bad guy. So we're loading X with our bad guy, which is 0, storing it in the current one, then loading the X value. Is that the X value? I think it was the X value to start with, which is 13. Yeah, that's right, and that's the Y value. So, let's, number of exits, evaluate our current position. Now, we don't need to worry about that too much because we know that bit works. Right, here we go. Right, store So it's got 4. Oh, 4. Right. So we are 04. Oh, constants. Where's the constants? Here we go. So 04 is east. So it says we're going. It says the only way is east. So we are talking there. That must be the middle of the screen there. So going east is right. Okay. So let's see. Not going and doing that. We're not doing that. We're not doing that. And we definitely are doing that. So load 0. Load that. Compare it with 0, which it's not. Load 2. 2 is definitely 2 is east, isn't it? Yeah, is right. Okay. We are stuck. Oops. We load our X. We store it. Increase our X. Load it back in. Branch not equal, and it goes back. Where is that? Where's that gone? Oh yeah, so we're testing for 1. Branch if not equal. We have 1. Right, okay. So now it's going to do the move. So we work out our colour position on the screen. Load our bad guy, which is 2. That's right. So load 02. Store it. Load the guy. Load where we're going. Decrease that, jumped. Right, so this is working our colour. Right, so load that, store colour. Right, there's our colour. It says, so at that point it says we've only got east. Really? Right, F10. Right, so now it's come to it again. So this is our current position here. So our only exit is down. Why did it say east? Because that's not right. I'm thinking it was there. That's what I'm saying. I think it's come from there because it did a decrement, didn't it? It went down. I think I've got my code wrong. Where's the move? Let's evaluate. Where's the move? Here we go. So if it's going right, oh, right, left is 0. Okay, so it's not doing that. But, I'm not sure. Right, last move, here we go. 3105. We'll keep an eye on that. Right, so that's working out where we are. So we've got 04. So it's still saying that we can only go right. Yes, that we can only go right.
Right. We call them herbs. Herbs and spices.
So
What do you call them?
just make sure it picks it out. There we go. So it's loading 0, load 01. So we defaulted it to left, which is 01. But it says 1 is down. No, that's 3105 is 0. We've just loaded 3105, X. Oh, look at X. Oh, do you see the mistake? Do you see the mistake? Go on, have a go. I've just seen the mistake. Do you see it? Yeah, you are right. You are right. Well done, Grey Defender. Well done. We are we are screwing up here. LDA. That should be LDX. And we've done it because we copied and pasted it on everyone. Just make sure I haven't made that mistake further on. Right. Let's see if that sorts it out this time. Right. Here we go. Right, so we know this bit works, so we'll let it run through. So it's going to get the current position. And it's 04, so it's still saying that we can only go right. So let's see. There we go, 04. Load X with 0, that's better. Load right, we are on 0. How did we come from 0? Yes, we did. Ah. Ah. That would explain it. Let me just confirm that again. Load 4 is 2. So it's saying it's 2. 2, 2, 2, 2. Let's just make sure what 2 is. 2 is going right. Yeah, that's fine. If it's... Did it come from left? No. Loads 2. Stores it in the last position. Increases it. Yeah, I'm not sure. I think I've got my logic wrong here. So if it's up, did it come from down? Was the last move down? Yeah. Because it's still doing this. Okay, right, we'll go through it bit by bit so we understand. You alright, mate? Hey? Right, so we're going to go through it bit by bit. We need to understand exactly what's going on. Right, so it should stop when it comes to evaluating. There we go. So we've got one bad guy. So we only have to worry about the one bad guy. So we are taking its position and we're storing it. Now we're doing the evaluation. So it's going to go and work out where that position is in the array, which I'll just quickly zip through, and it loads what's there and comes back with it and stores it. Right, so let's get this into OE86. 08E6, sorry. So we know what's going on. There, right. Oh. You alright, mate? Alright? You good boy? Been a good boy? Right. So we know it's not 8. And we know it's not 2. And we know it's not 1. Right, here we go. 4. Yes, it is. So we load our bad guy. What was the different direction? Which is unfortunately left. That's why it's not working, isn't it? Because it thinks it's come from the left. So we've evaluated that we can only go right. So we've evaluated we can only go that way. All right, let me get me thing back up. So what's happened is we are here. This is where we are. And it's gone and said that our possible exits, our only way out is to go that way. But we've got stupidly defaulted, said that we have come from that way. And what is one of our rules? If you come from the direction and you're trying to go back to it, you can't do it. And that's what's happening. Because it's saying, right, we came from the right. We came from the left. And so it doesn't update it. So we're loading 0, adding 2, storing it. So that's wrong. That is wrong. That is wrong. On so many levels wrong. Right. So what we're saying is here, we don't need to do this. But we're going to default not to left, we're going to default to a number that we don't use. But I also think there's a problem here. Why are we doing that? We don't need to do that. And also I've done a stupid mistake again here. Oh no, I ain't. We don't need that, do we? Yes, we do. Stupid mistake again. But I don't think we need that. We need it for if we've got nowhere to go. We need to go back on ourselves. Right. Let's try. Let's sort this out. Wrong one. That's the one. Right, so load our current position. Right, store it. 04, so we're still going east. I hope we're looking in the right place, I'll tell you. Right, so it's not that, not that, not that. It's that. Right, load our guy. What was the last? FF. Right, here we go. If he's equal to Nero, no. Load A with 2. Load the bad guy index. Store it away. So our last... So we're increasing our bad guy. We load it in. Yeah, that is... Oh, that's increasing the number of exits. So we load the number of exits in. We check, have we got, so we've loaded the number of exits in. And which is 1, that's right, we've only got 1 exit. Branch if not equal to, is it just the 1, which it is? Jump out. That's right, because we've only got the 1 exit. So we should move right. So it's going to, so we're going to evaluate where we are. Change it to red. Load where we are. We're not 0, we are... Ooh! It's FF. Why is it FF? We stored it. I'm sure we stored it. Right, let's do that again. Let's go to the place 3510. There somewhere. That's where the memory is. Right. Do this again. Store it. Find where we are. Load where it is. Right, here we go. 3105. That's what we're looking for. So we're looking around here, this area. 3105. FF, there it is. That is the number. Right. And it with 1. 4. Load X is 0. Load FF. Compare it with 0. It's fine. Load A with 2. Ah. Aha ha ha ha. Right. Right. My bad. We're not storing it. We're not storing our position. We evaluate it. We test it. We're gonna say, "Oh, we're all right. We're not doing it," and then we just, because it's the only one, we don't tell it. So it leaves it as it is. It's my bad. Now it should do it. Oh, wrong one. I need to be in C64 debugger, don't I? Right, 3105. Let's get there first. So it was Control G, 3105. There we go. Thank you, Stuart, for that nugget. Brilliant. Right. So let's move this forward. So it's put FF in there, which is right. So I'm going to put a breakpoint. No, we'll let it run through just to make sure. Right. Load where we are. Grab it. Store it. 4. Here we go. 31. Load that. Not equal. So that should turn into a 2 in the available exits. We increase it. Load X, number of exits, is it 1? Yes it is. Decrease it because we've only got the 1. Load R, so it should be 2. Store it away. There we go. We are on a winner. Right, now it should move it. So we load our place, put the colour there, load 2. It's not 0, but it is 2. This is where we are going to do it. Increase 3103. Nice. Now we're going to set the colour to blue. There it is. Oh, it's in the right place as well. Right. F11. Now we're going to evaluate the spot. So this is now going to have 2 exits. So we should, right, evaluate where we are. Load it. Come back. So we've got 05. So 4 plus 1. So 4 plus 1. 4 plus 1 is that the available exits are east and west. Right? So we can go east and west. And according to that, that is right, east and west. Right, let's see if it only gives us the 1 exit. So 8, no. 2, no. 1, yes. Load the bad guy, load the current direction. Is it 2? Yes it is, forget it. Right, 4, yes. Load the bad guy. Is it equal to 0? No. Then make it 2. Carry on. So it should move. Right, so it's moved. So our possible exits now are right and down. Okay, so we'll just evaluate it just to make sure. Comes back, and it's come back with 3. So 3 is south and west, which is correct. Oh, we're on a winner here. Right. So when it's evaluating it, 2, yes. Load it. Load 2. Is it equal to 3? No, it's not. So we can go south. So that's what it stores it as. Then here we go. So we can go west, but we came from the west, so we bypass it. So the only one that's available is south. South. Yes, look at that. It's done it. So it's gone south. Oh, nice. We have got a wandering bad guy. Right, let's take that break point out. There's the break point. Right, here we go. Full blown. So we should end up with a wandering bad guy. Oh, it went wrong there, didn't it? Did it go wrong? Oh, it's got stuck in a loop now, hasn't it? Oh, he's carried on. Oh, it thinks it can go down there and it shouldn't have done. That's the randomization on the junctions. So it's still not 100%, is it? It should be going up there. Right, let's see what's going on there. So we'll put the breakpoint back in. But we'll put it there. Oops. You alright? Hey? You alright? Okay. Let me sort this out, mate. What's up? Hey? What's up? Alright. You stay there then. You stay there. Alright? You be good. Lie down. Lie down. Go on, lie down. Right. So let's step through the cycles. So that's where we are. So let's see where our sticking point is. So these should be all straightforward because it's a straight, there's no choice. So let's get to a junction. No, not yet. Right, there is a junction. Right, so let's see what it's going to do. Resets the number of exits, goes and finds where we are. Right, so it's got OE, which will be OE. Oh, my brain's gone to toffee. E. So 8, 4 and 2. So north, east and south. Okay, so is that what was available for us? North, east and south. Right, okay, so we can't go south. So it's got the choice of north and east. Yeah, so it's done that one. Right. We haven't got 2 and we haven't got 1. So now there comes the randomization. So we do the random. So it's picked out 0. Load 0, which is 1. Now 1 is west, so it's going to go west. How can it go west? Oh! Looking at the wrong number, John. Looking at the wrong number. It's going to go down. It's going to go down? But we came... Oh, we came from north, didn't we? Yeah. We came from that way. So it's decided it's going to go 1, which is down. Right. So it should go down, which it has. Right, so we'll carry on. Another junction. Here we go. So we should have another... Yeah, so we came from the north, yeah? So we'll come from the north again. So it's OD this time. Which is 1101. So 1, 1, 1. So it's saying we've got west, south and north. West? Where's south? There's no south there. 1101. 1. Whoa, why is it saying south? Oh, hang on. 1101. I'm going in the wrong direction. So it's saying we can go north, east, not south, but west. North, east, not south, but west. That's right. So let's see which one it picks out. So it's setting up the possible arrays. It's not equal to 0. It's not equal to 1. Right, random number. Here we go. Pick 1. It's picked index 1, which is 2. So it's gonna go right. It's gonna go right. Let's see. Yes, it does. Right, and that's gone back up. So it's the randomizer. So that's going to go back. Yeah. Right, we'll get it. We'll wait until it gets to that junction again. Ooh. Right, we'll see what it's doing when it gets to that junction. There. Right. Because last time it went back. Get where we are. E. E. All the ones. So it's saying north, east, south, no west. North, east, south, not west. Right. Okay, so that's right. Right. 1. Yeah, we can do 1. What was our previous direction? Yes, it went south, yeah. But the available exits are north, east, south, but not west. But we can't go north, yeah? So end it with 2. Lowered our value. Was it 3? No. So we can put 1 in the available directions. Lowered it with 1. Wasn't that? And 4. Yeah. Where did we come back from? What? Yeah. So that's okay. Yeah. So 2. Stores that away. Increase. So we've got 2 possible exits. Right, let's look at 3105. Oh, it's not 3105, is it? It's 08 dB. Here we go. So our possible exits are 1 and 2. So our possible exits are down and right. That's correct, down and right. So let's see what it picks out. So it's going to do the random number, yeah? So we haven't got 2 exits, we've got 1 exit, we've got 2. So we are going to pick a random number. Oh, because it was too big, it's now picking another one. Because it picked 3, and it's picked 3 again. Now it's picked 1. Here we go. So it's picked 1. So that's the index. So the index of that is going to be 2. So it's loading 2, which is to go right. Okay. So we're going to go right. Here we go. And then we're going to come back. And we're going to go through it all again. So we'll quickly whiz through it until we get to the point where it does the random check. So 3 is one direction and 1 is the second direction. Any more? No. So 3 and 1. So it's picked out that the possible 2 directions are going up and going down. Right, let's see which one it picks. Going to the random generator. So we got 2 places. Load the number. 3. Compare it with 2. It's too big, so get another random number, which is 1. So 1 is gonna be 1, which is to go down. Okay, here we go. We're gonna go down. So go down. Right, so it's gone past that one. Oh, there's a long way before the next junction. Here it is. Right, so let's see what it's going to pick this time. So the possibles here are up and down. Up and down, which is 1 and 3. So work it out. So looking at the memory to see what it comes up with. So we load our condition and here we go. 3 and 1. They're the two it's picked out. We'll do the random number. It's come out with 2. So 1 is down. It's going to go down. Oh no, it's up. 1's up. Okay, let you off. Right. I don't think there's anything wrong. I think it's just the random nature of it. Because now it's continuing, look. Let's take the breakpoint out. F11. I think it's just the random nature of the junctions. Oh, there was a definite bug there. Ouch. Yeah. It seems to be on the up, doesn't it? Now it's got stuck. Oh, no. There's definitely on the up there. Can anyone remember where that address was? 31 something, wasn't it? C4. Here we go. Yes. It's this one here, isn't it? They are 3. That's the one. 3135. Oh, is it work on here as well? Oh, okay. Right. So there's definitely something going on. It thinks it can go up when it can't. So we're gonna see what we can find. So F10. Here we go. So now we're back here. So if I do F11, that's gonna move. Right. Okay. Let's see what it picks out. Right. So get our location. It thinks 7. I should know what 7 is. Yeah, all 0, all the 1s. So it says we can't go north, but we can do west, south, and east. West, yeah. Okay, so why did it go north? Okay. F10, let's see what it picks out. So it's picked out 01. It's picked out 0. Right, so it's picked out 01 or 0. So it's going to randomly pick one of those, 2. And it's picked 2, which is 0. But it's read 3. It's read 3. We've got two outcomes. Oh, John. We have two outcomes, yeah? Two outcomes. So it's always going to pick 0, 0, 1, 2 or 3. Absolute Wally. Utilities random. Let's see what... Oh, here we go. X is the maximum number for the randomizer. Right, okay. So that's... Okay, that's the problem. We're sending in 2. But in fact, that's 3. 0, 1, 2 is actually 3 elements. And we only want 2 elements. So in this randomizer, we need to DEX. Right. That was the problem. We had 2 exits. It comes back with 2, which is right, 2 exits, yeah? But the randomizer is going between 0 and the number, 0 and 2, which is actually 3. So to make it come out with 2, we need to decrease x by 1 to be 0 or 1. Right. Come on. Oh, don't just go in a circle. Come on. There we go. Now it's going to go all the way back. You're not going to go all the way back, are you? Oh, it's going to go all the way back. Oh, no. No, it ain't. Right, we seem to be on a winner. So this is just purely random. I don't see why not. Right, let's put 2 on. Let's see if it works with 2. So number of bad guys is 2. And see if they split up. So at the moment they're both doing the same thing, yeah? There we go. Right. Okay. Let's put it up to, let's say, 5. So they're all together until they get to a junction and then they'll start splitting. So we got 2. There. Oh, look now. Well, there we go. There's the 5. Yes, to start them in random locations, yeah. So, but we can do that in the initialize, right? Because we can do that in the initialize here. So instead of doing divide by 2 on the X, we can we can do the if we do X that, so max X is 39, so LDY is the mask, so 39. So if we say that's 128, 64, 32, and then do ones. 1, 2, 3, 4, 5, 6, 4 and 4, and then do JSR utils.rand. That will give us a number that then we can store in X, and then we'll do the same for Y. So Y is 24 maximum, so that is 31. So if we knock one off that as well, yeah, right, so that should randomize the start positions of those 5. So here we go. Kaboom! Oh. Ooh, Jam at 0920. Let's just see what's going on. Right, so store that, load 27, 1F, do the randomizer. So that came back with 0. That's that's no good. That's no good. 0's no good. So we need to 0's no good. Yeah, so what I've just done, mate, I've just added 2 instead. Oops. Just take the breakpoint out. Ooh, wrong place. Right. Kaboom! Why is that doing that? Oh, I see why it's doing that. Hang on, hang on. We are that. Maybe the computer needs to cool down. Oh, it's crashed again. Why is it crashing? Right, let's find out what's going on there. Cheers, mate. Oh. That's stuck in the random loop. That is definitely stuck in the random loop. Oh, I see. I see. There we go. They all put in zeros all the time. Okay, let's. Yeah, it's strange that it's coming back with 0 all the time. Right, let's put a breakpoint there. Right, load 27, 1F. Oh, why does it come with 0? It's definitely coming with 0 all the time. Oh, do I need to initialize it? Hang on. I haven't initialized the randomizer. Right, let's see if it's doing it right now. There we go. Has it? Okay. Oh, I'll see in a bit. It's still all come back the same. It's still all come back the same number. 1 6. One 8. LDX 18. We're going to do that. Just come back with E. Goes to the next one. Let's come back with 14. Right, let's put a breakpoint here. F10. F11. Right. Get rid of that one. F11. Right, that's done it. So 3103. So it's picked out random numbers. It's picked out random numbers, okay. So we will put a breakpoint there. F11. So load X is 0, so OF OA. Okay, what's the next one? So X X is 0. It's loading the same one again. It's loading the same one again. X is 0. See you later, Adam. Yeah, it didn't run through. It didn't run through all the. It didn't run through all of them. What we got a problem here? Load X. So we're loading a number of bad guys, storing it there. Then we are loading it back again. Oh, hang on. No. John. Bad boy. It's this one here. Store X in current bad guy. Current. Right, that should do it. Should be proper now. There we go. 5 randomly placed. Yeah, you're right about the timer. We'll have to look at the timer. So we've got 5 randomly placed bad guys, just randomly. So that works for the randomly placed guys. So what we need to do, probably in the next stream, is to try and work out some AI. So we're not got them all randomly wandering everywhere. Yeah. Well, I think that's been a bit of a success. We've now got bad guys wandering around. and now we just need to think about how we're going to have some AI. So we've got the random, random pick. Maybe we need some AI. So, weighting. If we are below them, then we weight the downsides, I suppose. Alright then, guys, well, that has been a bit of a success. I will put this code onto the Patreon GitHub tonight, so the patrons can have a look at what I'm doing and have a sneaky nose. So that's a benefit of being a $5 or above tier patron, because you can get access to the patron code, which you patrons get to see before the public gets to see. Yeah. Alright, well, thank you very much for joining me, and I will see you in the next stream, which will be next week, I think. Alright then, well, take care, guys, and thank you very much. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.